In this video, we'll look at 6 and 7. So on number 6, Phil inherited his father's Porsche, which has recently been appraised at $30,225. Its value has depreciated consistently at an annual rate of 9.5%. How many years ago was the car worth at least $65,000? So we can see here that the current value is $30,225. If the value has depreciated consistently at 9.5%, to find the multiplier in this scenario, we need to do 1 minus the multiplier, or the percent, since it's depreciating by that percent. So 1 minus 0.095 is 0.905. And if we're saying this is the initial value, then if we're answering the question about how many years ago was the car worth at least $65,000, that means this time should be a negative number. Another way you could approach this problem is to consider that the initial value is $65,000. So if you set it up that way, this was a certain number of years ago, it was worth that much. It depreciated by 9.5% every year, so that would be our multiplier. And then a certain number of years have passed, and now we know the car is only worth $30,225. So depending on how you look at it, if you use this equation, we need to guess and check how many years it would take to have gotten to this value. If you approach it this way, you're working backwards to figure out when it was worth $65,000, so you're guessing negative values of t to make this happen. You should get the same answer either way. As far as guessing and checking here, just pick a number, try it out, and then see what happens. So, for example, if you think that it was 5 years ago, 30,225.905 to the, in this case I would want to pick -5 as my exponent. Okay, 49,787. We want the car to be worth at least $65,000. So I'm going to guess more years ago. So let's change that to 6. Okay, still not worth $65,000. I'm going to guess 7 years ago. Okay, and there we go, it's worth at least $60,000, so we can say approximately 7 years ago. Alright, in number 7, in 2014, the population of Puerto Rico was 3.5 million. Its population is declining by 1.2% each year. How many years will it take for the population to reach 1.4 million? So 3.5 million, so I'll just say 3.5, and since the population is declining by 1.2%, the multiplier would be 1 minus 0.012, which is 0.988. Okay, how many years? We don't know, and when will it reach 1.4? So here we have another guess and check situation. It turns out here that it will take approximately 76 years for that to happen. If we plug in after guess and check, if you get to that, you will get 1.398 million. If you guessed 77 years, it would be smaller. If you guessed 75 years, you would be over 1.4. So it's an estimate. It would be appropriate to put 75 or 76 years in this case. What will be the population in 2045? So between 2014 and 2045 is a total of 31 years. So using our same equation here, 3.5 times 0.988 to the 31st power. is approximately 2.4 million people.